All right, good afternoon, everybody. Good afternoon. Sorry, we're getting started a few minutes late. The Apple TV is not working, so having to use the computer today. Took a while to remember how to do all that. Use the iPad for quite a few years now. So yeah, so we're gonna dive back into the joints today. Just a few reminders for the rest of the week. So obviously lab today. Make sure you have those lab handouts with you as long as well as your dissecting kits. Okay. And then if you are, yeah, the tutorial session is tonight, as always on Wednesdays, and then then we'll have the one again on Monday night, the review session for the class. If you are not in the lab that is happening right after this class, then that session I had told you guys about, the one that is, it's about metacognition, which is pretty much just like learning how to learn, which I think is really, really valuable. That there's a Zoom session on that today at I put it in Canvas as a reminder, but I think it's like 4 o'clock today on Zoom. I put the Zoom link in there in Canvas, so I recommend hopping on there if you're interested and you're not in that lab. It will be recorded too, in case is that what you're wondering? Yeah, if you guys are in the, half of you are in the lab during that time. So but I can definitely get that recording sent out to afterwards, but really, really helpful stuff on just kind of learning how to learn in a deeper way and in a more effective way, and learning how to study as well. So yeah, so that is today. Or just remember Friday's class, we won't actually be in class on Friday. Okay. I already have the video posted in the same place you find all of the recordings for class. There's a link there. Okay. So that'll take the place of class on Friday. Okay. And then Monday we'll have our TBL day, which is the first kind of exposure to learning the muscles. That'll be the hip and thigh muscles. Okay. So really, when you look at the muscles, what you want to know is you want to be able to visually identify the muscles, like on a drawing, on a diagram type image of that part of the body. You want to know, primarily I'm concerned about function in this class. Okay, so there's origin and insertion of every muscle, which I want you to know kind of more just in general for this class, which means the bottom line there is what joints does it cross over? Right, and then which part of the joint does it cross over? Okay, so for example, if we have a muscle that starts up here on the pelvis and goes down to the femur, we know it crosses the hip, we know it crosses the anterior side of the hip. So that means when it shortens, it's going to cause hip flexion. Okay, if you can get a little bit deeper to remember those origin and insertions exactly, that's even better. But the first step is really, let's figure out what the function of each of those muscles are. And to get the function, if you know the origin and insertion, at least general, and you know what part of a joint one crosses over, then you can know what it does, right? So if it crosses over the anterior side, it's a flexor. Crosses over the lateral side, it's an abductor. Crosses over the medial side, it's an adductor, right? Crosses over the posterior side, it's an extensor, right? So just kind of those basics are the most key parts first. And then some muscles cross over two joints, right? So your rectus femoris is one of those, crosses over your hip, also crosses over the knee. So that means it has to have actions on both of those joints too, right? So those are the kind of things you really want to focus in on, being able to identify, knowing what it does as far as actions, and really didn't get at those actions. You want to know what joints it crosses over and which part of the joint it crosses over that. Okay, so we'll start out that on Monday with the hip and thigh muscles. But again, that stuff on Monday is not on the next exam. On Wednesday, it'll be on the one after that. Okay, so the stuff that we cover for Friday's class via the video, that'll be the last stuff on the exam. Okay, and the quiz this week is over those stuff we did Monday and stuff for today. Okay, questions about any of that? Okay. All right, I feel so weird not holding my iPad. I'm so used to it. Okay, I think I can still do it this. I see. I can't even do this. Not even working. All right, let's try. I think I just need to click right there. There we go. Okay, let's start with this one. Go ahead and talk about this with the people on your team. And I know we didn't finish up that last thing on the shoulder, but we'll get to it here when we talk about the shoulder today as well. Okay, so go ahead and yeah, talk about this one with the people on your team. And go ahead and vote when you're ready. See, the one benefit of this is you'll actually get to see the bar graphs because they're on the computer. But all right, go ahead and send those in when you're ready. We're just missing a couple, so probably a couple more of you. That looks about right. Okay. All right, so now you can actually see the graphs. Isn't that cool? Right? Yeah, I know, so much better, but too tricky when I'm using the iPad. Okay, so you guys have no idea. That's the bottom line with that one. Okay. All right. So what joint connects the shoulder complex to the axial skeleton via a bony articulation? Okay, so that means bone to bone. If we think about the shoulder complex, which includes the scapula and the humerus and the clavicle, right? The scapula is really just like sitting on our backs, like kind of with muscle between, or there's really no bony connection of the scapula, right? The humerus connects to the scapula, right? So really the only bony connection with the shoulder is right here, right? So it's where your clavicle connects to your sternum right there, that sternoclavicular joint. So C is the correct answer here. So it seems kind of weird for this big joint to really only have have that one bony connection, but we'll get into this. Sorry, I'm going to be running back and forth a lot today, it seems. Okay, let's try that again. All right. Okay, so let's talk about the shoulder. When we talk about each of these joints, we need to think about, number one, which bones are a part of that joint. Okay, number two, which bony articulations do we have within a joint complex? Okay, when we're talking about a joint complex, we're talking about a bunch of individual articulations typically. Okay, and then we'll talk about some ligaments that are important for each of them, and we'll look at some injuries for each. Okay, so the scapula again is kind of almost floating on our backs, right? It kind of goes up and down our backs, floating. So we got the humerus, got the sternum. And really, there's two parts to the sternum. There's the upper part, the manubrium, and that's the part that it connects to, and then the clavicle. Okay, the clavicle gets the prize of being the most broken bone in the human body. Okay, very thin little bone, but it has kind of a unique shape to it, as you guys remember by looking at it, almost like a little bit of a mini S turn in it, which gives it the ability to kind of flip over and rotate almost when we abduct or when we flex our shoulder. Right, so it has this unique shape to it. Okay, so we got 4 bones as a part of the shoulder complex. Okay, and then the joints or the articulations as part of the shoulder complex. Number one, the glenohumeral joint. That's the one we think of when we think of a shoulder, right? Where the humerus comes up and meets the scapula, right? The ball and socket joint. But then we got that other one we were just talking about, which is also known as the SC joint, right? The sternoclavicular joint. Okay, so definitely write in SC there. That's what it's typically abbreviated as. And then the AC joint, the acromioclavicular joint, that's the one out here on the end of your clavicle where it connects with your scapula there. Okay. And then this one isn't really a true joint, but kind of this spot in here, right, where the scapula kind of rubs up and down on your back. Not really a bony articulation, but it is this kind of place where the scapula is moving up and down constantly. Okay, so there's in the shoulder complex, we got 4 bones, 3 true articulations. Okay, so let's look at each of those joints a little bit here. So start with the SC joint, okay, the sternoclavicular joint. So the articulation between the sternum and the clavicle, okay, so it's right here, okay. One of the best ways to learn this stuff is to feel it on your own body. You're your own model, right? You can feel that. So let's do it together. So touch your clavicle, which is right here in the middle, right? Grab onto that clavicle. Should be able to kind of grab it a little bit, and then walk your fingers medially towards your sternum. Okay, and you should feel a little spot where your clavicle kind of comes up a little bit first. And then right after that spot where it comes up, it dips back down, right? And you feel that spot where it dips back down, and it's probably a little bit sensitive right there too. The SC joint is typically a little bit tender, but it kind of comes up. There's a little bit of a lip on the end of the clavicle, and then you feel the joint space right after that, right? And so then do this. Sorry. Don't do that because you don't have something in your hand, but have your finger on that joint space, and then move your arm up and down and you can feel your clavicle kind of spinning in your sternoclavicular joint a little bit. That hurt on anybody? If you push hard enough, it kind of hurts. But yeah, that's your SC joint right there. It's yeah, remember that one has a little meniscus in it too, just like your knee, but a little tiny meniscus that is found right in here. Okay, this can be a pretty painful one when it gets injured because you actually move it all the time. It's constantly having movement to it, so it can be pretty painful if you sprain that joint. Yeah, so AKA SC joint. Okay, so that's the first one, SC joint. Next one, AC joint. Okay, so a acromioclavicular joint. So that's on the other end. So let's feel that one too. Let's walk your fingers out to the distal end of your clavicle. This one doesn't necessarily have that little lip first, but eventually you just kind of find yourself in this little soft spot where it dips down, and that's this joint space right here that we're feeling, right between the clavicle and the acromion, right, which is your scapula. Okay, again, try to just kind of move a little bit with your finger on there. If you're a overhand athlete, like a thrower or volleyball player or something, you might have a little bit more crunchy stuff happening in there when you do that. Does anybody feel some crunchy stuff moving around? Everybody's raising their hand, but yeah, some yeah, you just feel it. Yeah. How many has anybody separated their shoulder? Anybody? That term, shoulder separation. Yeah. So when we do a shoulder separation, well, first of all, we'll go in order here. So articulation between the acromion process and the distal end of the clavicle, okay, aka the S or the AC joint. Okay. When so the injury called a shoulder separation is an injury to this joint right here. Okay, it's not dislocating your shoulder. That's a different thing. Okay. Dislocated shoulder has to do with the glenohumeral joint, but the AC joint is the one implicated in a separated shoulder. What it is typically there's a lot of downward force on the acromion process, either because you hit somebody like this and it knocked it downwards, or you just land on your shoulder, right? And you push your acromion down and your clavicle goes the other direction, right? So your clavicle goes up, acromion goes down, you tear these ligaments right here, right? And you see this big thing sticking up in somebody's right here, right? There's this big bump there, right? That's not a dislocated shoulder, that's a separated shoulder. Is that what yours look like when you did that, Alyssa? Yeah, okay, yeah. Yeah, so here's the mechanism. It would be something like this, right? And then we might see something like this, right? And you can see it in the X-ray. The clavicle is just not attached to the acromion anymore, right? And so that's a separated shoulder. In severe cases, it can be repaired. It can be kind of tacked back down to the acromion. For the most part, you don't typically have to, but if it's a bad enough one, then it will have to be kind of tacked back down. How about yours, Alyssa? Did they have to do anything to it, or just heal up on its own? Healed on its own. Yeah, that's good. Yeah. This one you can't see too well, but it's pretty tough sometimes to tell the difference between a clavicular fracture and a shoulder separation, right? Because a clavicle fracture can look just like that too, right? Because your clavicle can kind of break right in the middle and then part of it sticks up. This is actually one of my kids' shoulders, Christian. Show you as many of my kid injuries here as possible. But this is the X-ray. So he fell off the back of our couch. They were like jumping on the couch. He like fell off, landed on the tile, and hit right there really hard. And he had a big bump right here. And I couldn't really tell whether it was the clavicle broken in half or whether that was his clavicle, at the end of his clavicle sticking up, like it was a shoulder separation. Yeah, but X-ray showed it's not the best picture, but you can see the fracture right through the middle of the clavicle right there. So his was a clavicle fracture. But yeah, they look somewhat similar. So, okay, questions on any of these? Okay, so the last one, let me get that clicker thing out of the way. There we go. Okay, so last one here, last articulation in the shoulder is the glenohumeral joint. I have to go back and put the cursor on the right spot so that works. This is just throwing me off, you guys. All right, okay. Yeah, so articulation between the humerus and the glenoid fossa of the scapula. Okay, like I've mentioned before, the greatest range of motion, greatest mobility of any joint in the body. Okay, it's kind of known as the golf ball on a tee, right? So we have this big round convex surface, which is the head of the humerus, right? And then this little tiny concave surface that isn't very deep at all, and it's not even anywhere close to the size of the ball that goes into that socket, right? So it's kind of known as this golf ball on a tee, right? So this big round head, tiny little tee that it's supposed to fit in, okay? So as far as if we go back to the last slide of the last class, right? The level of structural support we have in the shoulder, pretty low. It's one of our lowest. Okay, so as far as bony structural support in the shoulder, very, very low, right? This is one of our lowest. We don't get much structural support at all from this setup here. Okay, so it lacks ligament or lacks bony support. It also lacks ligamentous support. We'll look at some ligaments on it here in a second, but the ligaments that it does have surrounding it are pretty loose and not very supportive, which is why it has so much range of motion and why we can do all kinds of stuff with our shoulder. But at the same time, it also leaves it very prone for injury. Okay, so shallow glenoid fossa, about a quarter the size of the humeral head. And yeah, so let's look at some of the ligaments here. Okay, so we have, there's a bunch of them, but these are the two that I want you to know. So the coracohumeral ligament, and just like joints, how joints have the name of each bone in them typically, right? The acromioclavicular, glenohumeral joint, all those, the ligaments are kind of that way too, but with bones, right? So coracohumeral ligament, right? So it goes from the, what would be the coracal part? Coracoid process, good, with a C, not the coronoid process, right? yeah, those ones are tricky. So coracohumeral, right? So we're going from the coracoid process, that little thing that sticks out right here on your scapula, right? And then over to the humerus, right? So it's really just kind of this section right here. We can see it. Okay, so that is going to resist movement anteriorly, so keeping your humerus from going up, but then also, or sorry, anterior forward and then superiorly. So it's kind of like this direction, right? So picture what would tighten this up when the humeral head comes a little bit forward as well as up at the same time. Okay, and then the glenohumeral ligament is one that's really three different ligaments, but it's primarily keeping our humerus from coming anteriorly, right? It's primarily keeping it from popping forward this direction. And that one is very, very weak, pretty loose. So it can be a common thing to dislocate your shoulder that direction, right? Your humeral head comes forward and dislocates. Okay, so we got bony or structural support is very low in the shoulder. Ligamentous support is also very low in the shoulder. Okay. Musculotendinous support is kind of what the shoulder has to rely a lot on because of those other two things. Okay, so one of the most important ones here is this tendon right here. Okay, so biceps brachii. Biceps means it is two, right? So two heads, two-headed muscle. It comes up, splits into two. The short head goes right to that same coracoid process we were just talking about. Okay, but then the long head goes up, wraps around the humeral head, right between those two little structures, right? What are these guys called? What's this one called and this one called on either side of that? Greater and lesser tubercle, right? And then we have that intertubercular groove. I don't know if you guys didn't have to know the groove, did you? Right? Yeah, but it's just the spot right between the two. That's where the long head of the biceps passes through. Okay, and there's ligaments on top of it to hold it in place. And you can imagine when that biceps tightens up, it pretty much pulls the humeral head towards the scapula. Right? Just imagine this band here tightening, it pulls the humeral head in, right? So that helps support the shoulder quite a bit. Okay. And then it attaches actually to the top of the glenoid fossa, partially on the labrum. We'll look at the labrum in a second. So one type of injury is called a slap lesion, which pretty much means the biceps tendon rips off of the scapula, but it pulls some of the labrum with it when it does that. And so yeah. Anybody had an injury like that? No? Okay, good. Yeah, that one requires surgery. Okay, and then the other one, the other main set of muscles that are really, really important for stabilizing the shoulder are rotator cuff muscles. All right, so we've got 4 of them. Okay, and most of them either insert, well, one of them inserts on the anterior side of the humerus, and then the other 3 insert either on the top or the posterior side. So they pretty much, if this is my humeral head, they pretty much make a half circle, more than a half circle, all the way around that in the way that they attach to it. And so when they all contract together, they pull that humeral head towards the glenoid fossa. Okay, so the functions of these to pull or to cuff the humerus into the glenoid fossa. But then they're also very important, what's called decelerators of movement. Okay, most time when we think about muscles, we just think about the acceleration part. When we want to throw a ball, we're thinking about internal rotation. Okay, but as soon as we let go of that ball, if we don't have something slowing us down, then we're going to hurt our shoulder, right? So it's those external rotators that have to slow down that internal rotation that we started. And so these two muscles in particular are going to be helping out with that, because those are both external rotators. So they're very important for that deceleration process. And we'll talk more about that when we talk about muscles more. Okay, but you can remember these four muscles with the acronym SITS. Okay, SITS. Right. So the first one is supraspinatus. That's the one on the top. Infraspinatus is next. Teres minor is next. And then we flip over to the anterior side and subscapularis. Right. So SITS. Okay. Questions on any of that? All right. Everybody got that? Okay. Okay. All right. Go ahead and answer this question with the people on your team. Go ahead and turn to each other. Make sure you're on the same page here. All right, looks like we got everybody. Let's see what you said there. Good. So almost all of you are saying C. Okay, so subscapularis, right? So if we go back to the previous slide, you'll see that there's only one on the anterior side, and it sits underneath the scapula, kind of between the scapula and your back. That's why it's called the subscapularis. Okay, the other three are posterior here. All right. Okay, so then one more piece of anatomy here that's helping the shoulder have some stability is the labrum. Okay, so the labrum here is a lip of fiber cartilage that surrounds the joint. Okay, so it's not exactly like a meniscus where it's like a pad, but it really just kind of surrounds the outside of the joint. Okay, and it helps to deepen the socket by quite a bit. Okay, without this labrum, our shoulder is even more stable than it already is. Okay, but it increases the contact between the humeral head and the scapula by 75%, almost doubles the amount of contact that those two bones have. So very, very helpful in giving some more stability to the joint. Okay, back to last slide of previous packet. Okay, that's what we were just working through. Go ahead and flip back there just to make sure we're on the same page there. Okay, I remember right at the end there where we had to fill in the support levels for each of the different parts of the shoulder. Yeah, where it says joint stability practice, shoulder. Okay, so what do we got as far as bony or structural support goes? Pretty bad, right? Yeah, very bad. Very low structural support. Okay, what's the next one? Ligamentous. Ligamentous, where are we at? Bad as well. Very loose, very unstable from the ligaments. Okay, and then what do we go to next? Cartilage. Cartilage is helpful for sure. The labrum is definitely helpful. Definitely want to put that labrum in there. Increases the contact area by 70%. Very helpful. Okay, and then lastly, musculotendinous support. Helpful for sure. We got the biceps. We got the biceps brachii, most in particular the long head of the biceps, and then we got those four rotator cuff muscles that are there mainly just to help support the shoulder. But again, it's that balance of, yeah, we're making it sound like this. It's a bad thing that the shoulder's so loose, but it couldn't do what it does if it wasn't so loose, right? So it's just kind of that trade-off. Okay, questions on any of that? All right. Okay, go ahead and talk through this one, people on your team, and answer when you're ready. All right, so send that in when you're ready there. Just a quick reminder to everybody. I know it's tempting to have your phone sitting on your table, but I also know that even if there's no notifications happening on your phone, it's still distracting you. It happens to me when I have my phone out sitting there next to me. I'm thinking about it. It's like my little friend that wants to say something to me, right? So I just highly recommend just put it in your bag. That way there's just no chance of it actually distracting you. Okay. Thanks. All right. Okay. Let's see what you guys said here. All right. So yeah, about 75% of you are saying D there, which would be glenohumeral, acromioclavicular. Absolutely. So shoulder dislocation is typically talking about that humerus and the scapula. And then the acromioclavicular joint is that one that pops up when that clavicle kind of separates from the scapula. Okay. Questions about any of this? All right. Okay, let's move on to the elbow joint then. So the elbow is composed of two real specific bony articulations. Okay, so the humerus and the ulna. So obviously humerus here, ulna here, right? So we have the big trochlear notch that goes up into the trochlea. Okay, that's the one that's going to do this for us, right? That's the hinge joint. So that's the one that allows us to do flexion and extension. Okay, so flexion and extension of the elbow. Okay, but then we have this other one here too, this radio-ulnar joint, right? Where that round head of the radius meets up with the radial notch on the ulna, right? Remember that little indentation on the ulna, right? And so when we do this, when we pronate and supinate, it's really your radius spinning in your ulna, right? Your ulna pretty much stays in the same spot because I'm grabbing onto my ulna here by grabbing my elbow, right? But the radius is now on the other side of the ulna, right? So it's pretty much spinning as the ulna stays in place. Okay, so that's what allows for supination and pronation. And that's one of those pivot joints, right? Just allows for a transverse plane movement. Okay, this is also involved too, and the capitulum, right? The round part of the ulna fits nicely into the concave surface of the top of the radial head too. There's not always a direct connection with those, kind of like it shows here. There's a little bit of space separating those, but with compressive loading, that fits right up on there, and then it kind of helps spin along the ulna too. Okay, so those are the two primary articulations here. All right, so then let me move that thing. So then the joints, or sorry, the ligaments involved. Get this guy out of the way. There we go. So the elbow ligaments involved. There's a couple important ones here, and these are, especially the one on the medial side, is commonly talked about in baseball. This one here, the ulnar collateral ligament. Okay, so when baseball players, pitchers in particular, cock back for throwing like this, they're opening up this medial side of their joint, right? They're putting strain on that medial side of the joint, especially when they come forward, right? And their arm is kind of lagging back like this. It's opening up this spot right here, right? Or at least it's putting stress on that spot right there. So that's called the UCL, the ulnar collateral ligament, right? Ulnar collateral ligament right there. Sorry. Cursor's got to be in the right spot. There we go. So that's the UCL. It protects against what's called valgus of the elbow. Valgus, we'll talk about valgus in the knee in the elbow. It's when there's some kind of force coming from the outside and it opens up the medial side of the joint. So like I was showing you last time where I was doing the single leg squat and my knee was falling inwards, that would be valgus of my knee, but it could be the same thing in the elbow. When that medial side of the joint opens up, someone pushes you from that side, or you're just pulling it back this way, that's valgus. Okay. We have a ligament that's just the same, but on the opposite side, on the lateral side or the radial side, the RCL, the radiocollateral ligament, that one protects against varus. That's the exact opposite. If something's pushing us from the medial side and trying to open up the lateral side of the joint, that's varus. Okay. What's the surgery called when someone tears their UCL? Tommy John's. There it is, right? So that's a Tommy John surgery when we put that, have to put that ligament back together. And we'll show you on the next slide kind of how that's done. Okay, so there is the UCL sprain, right? It's torn. And what they do actually is they take this little muscle here. It's called the palmaris longus. So you guys can find your palmaris longus, and it's about 20% of people don't even have one of these muscles. So there might be someone in here that doesn't. Its main job is to tighten up the connective tissue in your palm. So if you kind of just do this, like you're trying to do like a cat thing, like wow, kind of like that, then you'll see this tendon pop up right there, right? So see a very prominent tendon that sticks up. That's most likely going to be your palmaris longus tendon. It's attached to this little tiny muscle that's literally about this big up here, right? And so when surgeons got in there, they thought, oh, that thing must not be doing much. Let's use it for something else. And so they cut this tendon off and they take it and they sew it in the place of the UCL, right? They do this like figure 8 pattern right there, and they sew it in place of the UCL, and that's Tommy John surgery. And yeah, who thinks they might not have one? Anybody? Not the UCL, but the palmaris longus. Yeah, yeah, you might not. Like I said, about 20% of humans don't have the palmaris longus. It is more useful in things like cats and other animals that use their claws more than it is in humans. So it's not present in all humans. So yeah, so that's Tommy John surgery. So much more common now than it used to be, with velocities increasing so much in baseball. And a lot of times people come back and they think they can actually throw a little bit harder, and sometimes that is true after Tommy John surgery. Sometimes their velocity increases a little bit, but yeah, it's about a 14-month recovery though. It's an incredibly long recovery process from Tommy John. So not just missing one season that you heard it, but typically the next season too. So questions about any of that? Yeah.
Why does the velocity increase?
Why could it increase? Like, what's the theory? Yeah. The theory is that so anytime you do a ligament replacement surgery, same thing with ACL surgeries, they have a specific tightness that they're supposed to put that ligament, right? And there's different opinions on how tight to put those ligaments. And so I've watched multiple ACL surgeries where yeah, they actually put the ligament in, they kind of get it locked down, and then they do a test on the ligament to see kind of how tight it is, and then they might need to make an adjustment depending on that. And so it's the same idea with this. If we get a little bit more tightness out of that joint, then it might have a little bit more spring to it, and it might create a little bit more velocity. That's one of the theories. The other theory is the fact that they spent 14 months rehabbing their arm, right? And so it's a lot of energy, a lot of focus on that arm, and yeah, so coming back, maybe they're just more strong, more ready to go. So yeah. Other questions on any of that? Okay. All right, so let's move on to the hip. Okay, so the hip is another ball and socket joint, right? So big, we talked about this one last time, large femoral head going into that acetabulum, right? And so yeah, pretty large range of motion as well, much more stable than the shoulder. Number one is because the socket's so much deeper, right? We got much more structural support, but also incredibly strong ligaments. And there's also a labrum too. Right, so a labrum similar to the glenoid labrum, but this one's called the acetabular labrum. So again, a rim of fibrocartilage around that deepens the socket even more than it already is. Okay, here's that iliofemoral ligament that I was talking about last time. This is kind of the one that if you're standing and you kind of like let your hips swing forward like this, you're pretty much putting pressure right on that iliofemoral ligament when you do that. And I think I said kilograms, which would be a major over exaggeration when I was trying to do this off the top of my head. But there it is, has a tensile strength of about 772 pounds, right? So incredibly strong ligament. Only can really get torn in something like a car accident or something with incredibly high forces, not something that can be torn typically with movement, just without an external thing making you go faster like a car, right? Yeah, so that's the hip. I won't spend much time there, but we will spend some more time here with the knee. So the knee is known as pretty much the largest and most complex joint in the body. Okay, it's a hinge joint in a way, but it's modified because it can rotate a little bit too. Hinge joints can typically only do flexion extension, right? But the knee can rotate a little bit too. And you guys are in the perfect position to feel that rotation, right? So as your knee is there bent at 90 degrees, if you just take your foot and move it in like this and then move it out, and have your hand on top of your tibia when you're doing that, you can kind of feel your tibia going like this a little bit, rotating in and out. And that's knee rotation. It doesn't have much, just a few degrees of movement either way. But that's why it's not a pure hinge joint, is because it can rotate a little bit like that. Okay, so there's 4 bones a part of the joint here. Okay, so the tibia, the fibula, the patella, and the femur. Okay, and then there's 3 articulations. Okay, so the femur and the tibia is the big one that we think about, those big femoral condyles rotating in the tibial plateau. The fibula and the tibia, right? So that's where your fibula comes back in up here on the top and connects to your tibia. There's a little bit of movement there, not much. That's one of those syndesmosis joints as well. Okay, but then the patella and the femur, your kneecap sliding over your femur when you flex and extend, that's kind of our 3rd articulation there. Okay, we got those menisci here, medial and lateral menisci. And these are very helpful in deepening the articulation, absorbing some shock for us, and then really helping to stabilize against lateral or medial movements, as well as rotation. Okay, so definitely help provide some stability with those menisci. Okay. Everybody got that written down? Okay. All right. Well, let's talk a little bit about the ligaments of the knee. There's a bunch more than this, but these are the ones I'd like you to know. So these ones I have crossed out, but just because you can kind of see them in this image, okay, is why I still have them there. But the patellar ligament is really a tendon because its job is to help the quads connect down to the tibia. But it's technically going bone to bone because it goes between the patella and the tibia, even though it is continuous with the quad tendon, which is up here, right? So it really has more of a function of a tendon, but since it's bone to bone, it's in some areas called the patellar ligament. Okay, and then we got the MCL, or the medial or tibial collateral ligament, and then the lateral or fibular collateral ligament. So those are typically known as the MCL and the LCL. MCL is on the medial side, LCL is on the lateral side. Okay. So the LCL, this is where I would draw something on my iPad, but the LCL is going to protect us against varus. Okay, so connect the lateral one with the varus one, and then the valgus one with the MCL. Okay, and then we got those ligaments on the inside that we can't really see on this image here, but the ACL and the PCL. Okay, so just briefly there on your clickers, once you answer that question, which one is the MCL? And check with the people on your team, make sure you're on the same page there. Yeah, go ahead and label them all while you're at it, if you know.
So this MCL.
But
Either.
what is like, I know something has frozen shoulders.
Mhm.
I read about it, but I didn't really understand. It's like the thickening and.
Of the
hardening
capsule.
of The capsule.
Yeah.
What, is it like a synovial capsule? or
Yeah,
what?
it's the fibrous part of the synovial capsule. Yeah. So yeah, there's that inner part that's the synovial membrane, and then the outer part is pretty kind of like a big ligament, pretty much like very ligamentous that holds that.
Okay, that's what I thought. I just said capsule. I was thinking.
Yeah, It's the fibrous part. Yeah.
Yeah,
Mhm.
it says like there's like 3 stages
Mhm.
and you can't move. as long
Can't
as
move it.
that's-
It's- Ouch, that's no good. Yeah. All right, go ahead and send that in. A couple more of you. Which one's the MCL there? MCL is also known as the tibial collateral ligament, right? Because it attaches to the tibia, whereas the other one on the other side attaches to the fibula. So the fibular collateral ligament. Okay, see what you guys said. Okay, so about half of you are saying D. Okay, and that's correct. So it's this one right over here, right? Not C. C and B are these patellar ligaments. That's why I still have them labeled on there, but those are helping to hold the patella down. Okay, but then we've got the MCL over there, and then the LCL is A there. Okay, so that goes from the fibula back up to the femur. This MCL is going from the tibia back up to the femur, but very important for valgus and varus, protecting our knees from moving in those directions. Okay, questions on that at all? Okay. Okay. What do you guys think? Take a guess here. Which one did this poor guy sprain? Do you see where we're looking? Right there? So which motion is that? Talk to each other about it, valgus or varus, and then which ligaments is he spraining there? All right, take a guess, A or B, send something in there. Okay. What you guys said. Okay, so about 80% of you are saying B. So that would be the MCL. Absolutely. This is definitely a valgus motion. That medial side of his joint, if this is the knee, or if this is the medial side, we're doing this, right? And that MCL is trying to stop that motion so that can tear or sprain the MCL there. Okay. All right. And then a little bit about the ACL and the PCL. Okay, so there's kind of two ways to look at the function of these. You can either look at it in terms of which way is the tibia moving on the femur, or which way is the femur moving on the tibia. Sorry, I'm trying to get this thing out of the way. There we go. Okay, so this says the ACL prevents the femur from sliding posteriorly on the tibia. Okay, so if we got femur here, tibia here, so the ACL is preventing the femur from going back on a stable tibia, right? Or we could say prevents the tibia from sliding anterior on the femur. If the femur is stable, doesn't let the tibia come forward, right? So it kind of is the same thing, right? It just depends on which one's stable. They're probably both moving in actuality, right? But it's preventing this from happening, right? Whereas the PCL is just the opposite, right? It prevents the femur from sliding anteriorly, so this from happening, or the tibia from going posteriorly. So one easy way to remember it, the most common way to sprain your PCL is in a car accident when you slide forward and your tibia hits the dashboard or the steering wheel, right? And then that slams your tibia backwards, right? PCL is not commonly torn in sporting activities. It can be, but the ACL is the one that's more commonly torn in sporting type things. Okay, so there's the cruciate, right? Why they're called that because cruciate means cross, right? So they cross over in the middle of the joint. Okay, when ACL well, actually I have a picture on the next slide. Yeah, okay, so questions on those? We're not going to have you do it with each other. Don't really have enough time. But. Okay. So, it's not moving at all. There we go. Okay, so when the ACL is repaired, there's a couple different options like we we're talking about last time, right? So there's this one called the a patellar tendon graft. So a little bit of chunk of the bone is taken out of the patella, a little chunk is taken out of the tibia, and then the middle 1/3 of the patellar tendon is removed. And then that is, then they drill a hole on the medial tibia, drill a hole on the lateral femur, right? Attach strings to it, run that thing through both sides, and then screw it down over here, screw it down over there, get that tension just right. And then it eventually kind of transforms itself back into a ligament, even though it's not a ligament to begin with, it's a tendon. Okay, this can also be done with hamstrings, with one of your medial hamstrings tendons taken out, kind of done that same procedure. And that's ACL reconstruction. It can also be done with a cadaver ACL or a pig ACL. There's multiple different ways to do it like that. Okay. It is somewhat more common in females for ACL sprains. There's lots of different reasons. Some of it's estrogen related. Estrogen has an effect of softening ligaments. Some of it is what's called Q angle related, where females obviously have wider pelvises for childbearing, and that just changes the angle that the femur is with the pelvis, and which can kind of tend towards valgus a little bit more frequently. And there's some other possibilities too. And when someone sprains their MCL, typically doesn't require surgery, but it does typically heal on its own. Okay, questions on any of this? Okay. All right, let's do this one here then. All right, anybody else go ahead and send that in? What do we got? Okay, we're 2/3 saying A, 1/3 saying B. Okay, so A is anterior posteriorly. Okay, so let's look at that. ACL prevents the tibia from sliding anteriorly on the femur. That is true. Whereas the PCL prevents the tibia from sliding posteriorly on the femur. That's true. So this is A. Yeah. Okay, if we were talking about the femur moving on the tibia, it would be the opposite of those two motions. Right, so tibia going anterior is the same as femur going posteriorly. Right, tibia going posteriorly is the same as femur going anteriorly, as far as in terms of what it would do to those ligaments that hold those two bones together. Okay. All right, last joint here is the ankle. Okay, so the ankle joint complex is made up of 4 bones again. Okay, the tibia, the fibula, the talus, and the calcaneus. Okay, the tibia and the fibula come together here to create what's called the crurus. Okay, so pretty much wraps around the top of the talus, makes this little like C-shaped thing that wraps around the talus. Okay, and that's why it's called the talocrural joint. Right, so the talus and the crurus come together, and this is where we get dorsiflexion and plantar flexion. Right, so that's the motion of pushing your toes down like you're pushing the gas pedal down. That's plantar flexion. Pulling them back up the opposite way, that's dorsiflexion. Okay, but then we got the joint between the talus and the calcaneus. So below the talus, also known as the subtalar joint, is the one that allows for inversion and eversion. Okay, so when you like roll your ankle, right, you're walking and you roll it to the outside, right, that's inversion. That's the inversion way. When you go the opposite way, when it comes in, that's eversion. Okay, another common injury we talked about a little bit with the syndesmosis joint here is the inferior tibiofibular joint, right? So that ligament that holds the tibia and the fibula together, that's really what's known as a high ankle sprain. That's when the ankle's in dorsiflexion. So the talus is jammed up in the crurus, and then you invert a little bit, and it just takes that fibula and kind of pushes it off of the tibia, right? And spreads out that crurus a little bit. All right, so ligaments here. We got 3 lateral ligaments. I want you to know their names. The most commonly sprained one is the first one here. It's called, abbreviated as the ATFL, but the anterior talofibular ligament. So it goes from the talus to the fibula, and it's on the anterior side. This one right here, most commonly sprained right there. And then we go this one here that's straight down off the fibula, down to the calcaneus, called the calcaneofibular ligament, or just the CFL, right? Calcaneofibular ligament. Second most commonly sprained there. And then when you get a more severe ankle sprain, you're going to get this one back here too as well, which is the PTFL, or the posterior talofibular ligament. Okay, so most commonly sprained, again, that ATFL, the anterior talofibular ligament. Okay, and then just on the other side, on the medial side, if you feel where your tibia comes down, that medial malleolus, you can sprain those ligaments too at the bottom of your medial malleolus. Those are called the deltoid ligaments, shaped like kind of like a pyramid. Those ones we don't sprain as often because when we try to evert our ankle, it hits the fibula on the other side. It can't go that far that way, right? We have bony support stopping it from going too far. But we can sprain them. And if we evert our ankle too forcefully, then we can sprain our deltoid ligaments as well. Okay. All right. We're good. Sorry. Yeah. Most sprained, ATFL, right here. Anterior talofibular ligament is the most commonly sprained. Oh, before that? Oh, yeah, it's the same one. I don't know why I had that question there too, actually. Yeah, thank you. Yeah, ATFL. All right. Have a good day, guys.
Thank you.
Yeah. See you next week, actually. Have a good lab today.
And exams next Wednesday, correct?
Next Wednesday, yeah. Hey. All right, bye-bye.